All right, in lesson 3.4, we're going to talk about polynomial multiplication. We're going to start with doing monomials times polynomials, and then we're going to move up to do polynomial times polynomial. Now, let's start with the monomial case. Remember, monomial just means that there's one term. If there's one term, like 2t, and we're multiplying it by t squared plus 3t minus 1, really all we're doing is we're going to distribute this 2t and multiply it by all three of these terms of the inside polynomial. So if we have a monomial, we multiply and distribute and multiply it times each of these terms. So we can look at that on this piece of paper here. 2t times t squared plus 3t minus 1. What's going on? You're going to take the 2t, and that's going to be multiplied by the t squared. And then you're going to multiply. Now, because this is going to get multiplied times a different term, I have to signify that we're going to do a different term, so I'm going to put a plus there. You're going to multiply the 2t by the 3t, and then plus, you're going to multiply the 2t by the negative 1. All right? Now, you'll notice that each one of these individual 2t times t squared, that's actually just a product rule, just like we did in section 3.2. So 2t times t squared, well, t, this is again t to the first power times t squared. We're going to add those exponents. So we're going to end up with a 2 times t to the third power. Here, we have to, not only do we have to add the exponent of 1 on this t to the 1 on that t, but we also have to multiply the coefficients. So we take 3 times 2, that's a 6. By the way, again, here we have a plus 6. And then t times t is t squared. So each one of these individual pieces, whether it's 2t times t squared, 2t times 3t, or 2t times negative 1, is basically just like a product rule, or is a product rule. Now, when we have a negative, 2t times negative 1 is a minus 2t, so, or a negative 2t, however you'd like to say that. You can either add a negative 2t, or just like I did here, I could write it as subtract 2t. So basically that's it. When we do a monomial times a polynomial, that monomial gets multiplied times each term in the inside polynomial. Now, most of the time, this middle step I'm not going to write. A lot of people, what they do is they'll write just lines on top to signify that they multiplied 2t times this term, 2t times that term, and 2t times that term. And then they'll just do all the multiplication in their head. So that's the idea of multiplying a monomial by a bigger polynomial, bigger in terms of more terms. You can see example 2 there, 3t squared times 5x. 3 times 5 gives us 15. X squared times x gives us x to the third. 3x squared times a negative 1, that gives you minus 3x squared. Again, that negative 1 times 3 just gives you minus 3. And then x squared doesn't have any variables to multiply when you're dealing with this term, so it just is left as x squared. In example 3, you can see they've multiplied y to the 5th times this polynomial. So they take y to the 5th and multiply it times each and every term of this polynomial. Y to the 5th times y to the 5th gives you y to the 10th, so you end up with 6y to the 10th as your first term. Y to the 5th times negative 8y to the 4th is going to give you a negative 8y to the 9th. Again, we're adding the exponents. That's that product rule. Y to the 5th times 2y squared. We get 2 and then y to the 7th. y to the fifth times y is y to the sixth. Minus 9 times y to the fifth is simply minus 9y to the fifth. And so that multiplying a monomial times any polynomial is just that. All right, just that technique. Basically, it's just a distribution into all the terms. And then we have to understand that when we distribute, we have to use our power rules. Now, you see on this next page the cooperative group problems. At this time, I'd like you to pause this video, try the cooperative group problems, and then come back to the video and I'll explain the cooperative group problems from 3-4A. All right, so hopefully you went ahead and did that. So let's take a look at these cooperative group problems. Hopefully I wrote down, yep, I got those correctly. So problem number 1 says take 5x, whoops, and multiply it times x to the third minus 9. Now, when you multiply 5x times x to the third, you end up with 5x to the fourth. So x times x to the third gives you x to the fourth. When you multiply a minus 9 times a 5, you get a minus 45. So 5x times minus 9 is going to be a minus 45x. So 5x to the fourth minus 45x is the answer to problem number 1. Problem number 2 says to multiply z to the fourth times 3z squared plus 7z minus 8. So I distribute. The first multiplication we're going to do is z to the fourth times 3z squared. You end up with 3z to the sixth. Z to the fourth times 7z, you're going to get a positive 7z to the fifth. Z to the fourth times a minus 8 is a minus 8z to the fourth. Again, each one of these is that product rule. Each one of these individual multiplications is the product rule. And that's it. That is our final answer. 6z to the sixth, or excuse me, 3z to the sixth plus 7z to the fifth minus 8z to the fourth. Now, when you deal with multiple variables, nothing really changes. You just have to remember how we use the product rule on multiple variables. When you take a times b squared and you multiply it times this first term, well, the coefficients, again, there's an implied coefficient of 1 out here in front of the a. 1 times 4 is 4. A times a squared is a to the third. Again, add the exponents. We have an implied 1 plus 2 gives you 3. B squared times b is b to the third. And that's our first term. In our second term, we're going to have a plus 3, and that's going to be multiplied times a b squared. So nothing with a like base there to deal with. And we just get 3 times ab squared as our second term in our final answer. So 4a to the third, b to the third, plus 3a times b squared. On problem number 4, scroll this down a little bit, we go 10x squared times the polynomial inside. The inside polynomial is 4x to the third plus 2x squared minus 10x plus 15. So multiply the 10x squared times all 4 of these terms inside. 10x squared times 4x to the third. Well, 10 times 4 is 40. x squared times x to the third is x to the fifth. Again, that's the product rule. The next term we're going to get is what we get when we take 10x squared and multiply it times 2x squared. 10 times 2 is 20. X squared times x squared is x to the fourth. Next term, we're going to get 10 times minus 10. We're going to get a minus 100. X squared times x is x to the third power. So our third term is minus 100 x to the third power. And then lastly, 10x squared gets multiplied by the positive 15. We're going to end up with plus 150 x squared. So 15 times 10 is 150. X squared times no variables is just x squared. So that's it. Notice that x to the fifth, x to the fourth, x to the third, x squared. Each of these four terms is distinct. There's no combining like terms like we did in section 3.3 because none of these terms are like terms with each other. Now the last problem that we have here, problem number 5, is negative 3y squared times the polynomial 7y to the fifth minus 9y to the third plus 2y minus 4. When you take and you multiply, well, the first term, negative 3y squared times 7y to the fifth, negative 3 times 7 is negative 21. Y squared times y to the fifth is y to the seventh. The next term, we're going to get a negative 3 times a negative 9. That's going to give you a positive 27. And y squared times y to the third gives you a y to the fifth. 2 plus 3 is 5. Again, notice that negative 3 times negative 9, negative times negative gives you a positive 27. Negative 3y squared times 2y gives you a minus 6 y to the third because negative 3 times positive 2 is a minus 6. Y squared times y is y to the third. And then the last term we are going to get here, negative 3y squared times the negative or the minus 4. We're going to end up with a plus 12y squared. Negative 3 times negative 4 is 12. And then obviously y squared times no variables is just still y squared. And so that is how we multiply a monomial times a bigger polynomial.